All right, Algebra 2 students, we are going to continue on our exploration of exponential functions, growth and decay, but real world situations. So instead of just talking about a generic initial value that is then multiplied uh, a certain amount of times by this multiplier, again, this is our initial, this b is like our multiplier. We're multiplying our initial value by this number this many times, depending on what we choose. We're going to say the multiplier is equivalent to 1 plus a growth rate. Okay, and we kind of investigated this towards the end of last class, is finding this rate. But this allows us to create these exponential situations and equations for real world situations where we're not like doubling, but rather we're increasing by a certain percentage. Here, we see we have a bank account that is paying 5% interest, and we started with $8,500. So this is what we would consider our R. Now, we're getting paid interest, so we're growing our money. So it's a growth. So to write our exponential function, our model, we're going to have 8,500, and then the multiplier will be 1 plus our growth rate. Now, our growth rate is 5%. We're not going to say it's 1 plus 5, and that would be multiplying this 8,500 by 6 every time. That doesn't make sense. We're only growing by 5%, which is why we need to turn this percent into a decimal. You could either divide by 100 or just move the decimal place over twice. 5 divided by 100 turns 5% into 0.05, the decimal. So 1 plus 0.05 is 1.05. And that's going to be to the years or to the time or to the x. It doesn't matter if you use t or x. We're good here. And this can be graphed so we can kind of see our situation. Now, if you graph using a graphing calculator, great. If you graph using Desmos, great. I'll show both. But one thing you notice in both situations, that you can't see anything. Shift 6. I think if you use T or X, it's fine. You can't see anything. Why is that? Well, we're starting at 8,500. We only can see values of y's from 0 to like 5 here. And here we can only see 0 to 10. Now, here's a helpful thing in a graphing calculator. Zoom 0 is zoom fit. Now, zoom fit automatically adjusts your graph so you can see the graph based on the x's that you choose. It might take a little bit while. You can see that calculator is working. But here is my situation of my exponential growth, where I have this initial value of 8,500. And if you press trace, you can then click on values to see, other values. After 1 year, you're at 89.25. After 2 years, you're at 937.125. And the question is like, what are we going to have after 6 years, and when will our account reach $12,000? Well, that creates kind of two equations that we have to find. So we need to find amounts after time, and then we're going to find when our amount is a certain value. So we start here with our equation for both, but then we got to understand, what do we need to find? Well, in this situation, finding the balance after 6 years, we're going to replace x or t with a value. So how long have we elapsed? 6 years. We're going to multiply our initial value by 1.056 times to grow by this percent, 5%, 6 years. And We can either get that in our home screen, but mostly we're going to look at our calculator for these answers. Okay, $12,057 is my Y value. Y is like my future amount. $12,057. If you're in your calculator and you're in the graph, you could also find this either going into your table or pressing this trace button and then saying, what's my value after 6 years? What did I type in wrong? Oh, I did 6%. Whoops. It's a good way to check. My bad. So 11,390. Whoops. 0.81. Okay. Or in the graph, trace 6, you get that 11,390. In Desmos, which you're going to be looking for your project, first thing to do is to adjust your y-axis. It doesn't really adjust it automatically for you. You're going to have to adjust it. So I'm going to go up to 15,000. I have that initial value of 0. And then I want to see what I get after 6 years. Now, what you'll find is when you click on the graph, you get all of these values, kind of like with your calculator with trace. But it's kind of hard to get right at 6 all the time. You notice that? Like I can't get, oh, there's 11,390. But here's another way to do this. You can say what your t is supposed to be equal to. And this is easier if you use x. And just replace this with x, t or x, it's the same thing. So you can see like after this many years, your calculator provides your intersection. So if I want 6 years, boom, I have the intersection here. X or t is years, y is amount. So that's really the most important thing, is to understand what this is. This is like your future amount. This is your time. So when you get x comma y points on your graph, understand this is time. This is like an amount or a future amount. So if I ask you, when will the account reach $12,000, you're wondering, what is your x when your y is $12,000? So I'm going to set up this equation. Now, we will learn next unit how to solve this. You can't solve this yet. You can't solve it kind of like using square roots, like you would think you might have to do to get this x by itself. We're going to learn a technique in the inverse of this exponent next class. So instead, all we're going to do is actually solve this equation graphically. Now, we learned last unit how to solve things graphically is like you can put y equals the left side and y equals the right side. And you can find where they intersect. Now, in your calculator, you'll have to go second calc intersect and find this intersection. And you can see x is 7.067. So that is the years to get that value. In Desmos, which we'll be using our project for, instead of having just an x equals, don't do x equals 12,000. Instead do when is my y equal to 12,000. And then you can see this intersection right here, 7.068, just like I got the other way. Okay, just rounding 0.678, which is 0.68. Okay, so the key to this lesson is setting up your equation correctly. If it's already given to you, great. Then understanding what your x's mean and what your y's mean. Your x's or your t's are like the time that's passed. The y's would be like an amount in the future. Okay, so the rest of them, they give you the equations. For example, we have a car depreciating in its value. Probably a question to be better is like you have a $24,000 car that depreciates at 15% a year. Now, since it's depreciating, we are losing value. If we think of our multiplier as being 1 plus r, well, we're going to say that my r in this case is negative 0.15. And that's how we can kind of get this 0.85, where we have our multiplier is 1 plus or 1 minus 0.15 or 1 plus negative 0.15. And that's how they got that 0.15. Now that's how you can find your percent rate of increase or decrease. Like R is, B is 1 plus R. Our multiplier now is turned into 1 plus our growth rate. Well, here we have B is 0.85. That's equal to 1 plus R. Subtract 1 from both sides. In your calculator, 0.85 minus 1 in the home screen. And we get negative 0.15. Now that is telling you that we are decreasing or depreciating by 15% a year, or we're decaying. Okay. What is the initial value? Our initial value, you can see, $24,000. And now, since we have the equation, we have the setup, what's the car's value in 3 years? And when will be the car worth half the value, half of its value? Again, we set up like an understanding of what our x's and our y's are. X's is like the time, y's are like our future amount. So 3 years would be like an x, and then half of its value. The y, when we're half of the value, would be 12,000. And then we can use our graphing capabilities to answer these two questions. We start with the graph of 24,000. .85. We adjust our y's so we can see. Maybe I go up to 25,000. Here is my initial value. Here's how my car's value is decreasing. We can adjust our x equals to find our value at a certain time. You can adjust your y equals to find your time when you get a certain value. I already have 12,000 as my y. That's half the value, so that's good. I can already find this point right here, 4.265. After around 4.25 years, my car is worth $12,000. $4.265. And then here, when my time is 3 years, what's my value? When my time is 3 years, what is my value? 14,739. If you'd like to do this using your graphing calculator, start out with your graph, 24,000 times 0.85, sorry, to the t. Let's clear this, though we'll need it. Let's zoom fit, which is zoom 0. Zoom fit gives me my graph on my x's from -10 to 10. I could adjust my x's to be like from -1 to 10. And if I zoomed fit, you can see a better understanding of like the positive times rather than the negative times. So maybe you do that. It's a nice graph. Again, you could get points by just pressing trace and then plugging in values. So after 1 year, you're 20,400 worth. After 2 years, your value is 17,340. After 3 years, and this can be found in the table, you have 14,739. If you're wondering when is the car going to be worth 12,000, when will the y equal 12,000? We'll graph y equals 12,000. We'll find the intersection, second calc intersect, enter, 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 and we get that 4.265. Okay, hopefully we understand everything. Probably for your homework, as well for the project, you're not going to be given the equation. You're going to be given like the values. Like you're going to be told the rabbit population is 9,302 bunnies, rabbits. It is increasing at 9% per year. From there, you then calculate what B is, changing this percentage into a decimal, and then going that B is equal to 1 plus 0.09, which is 1.09. Then you create the equation. Probably what I'll do in my classes is, have you graph and find the information, and then I'm going to change some values and then answer the same questions. So you have the equation to start with. We should know that this is my initial value. That's my multiplier. So my initial population in 2010 was 9,302. What are we growing by? Well, my B equals 1 plus R. Subtract 1. We can see that we're growing by 9%. It's a growth situation because we're multiplying this initial value by something bigger than 1. Now we have to answer the questions. What is the population in year 2023? Well, this is when my time is 13. How can we figure that out? It's like you started in 2010. This is 13 years after that. So this is the situation when we're finding the y coordinate based on the x coordinate. And here, when is the population going to double? We're going to have to use our calculator to figure out what the double population is. 9,302 doubled. 18,604. So we're going to say, what is the x value when the y value is 18,604? All right, I'm just going to use Desmos for this, but you can obviously use your calculator to answer the same questions. The equation is 9,305. Is that right? 9,302. (1.09) to the x. I can see what I want to see. Here I got my x that I can slide. When x is 13, I gotta bump this over to 13. Oops. Can't see 13. I can shift the graph over and up to see 13. I got 28,518. That's my point there on my graph. That is the amount of rabbits. 28,518. Go ahead and put the decimals down, even though it might not make sense to have like 0.115 of a rabbit. But we're just using this as a model to like predict. So we probably would say it's like just around 28,518 in your project, even though like it might not make sense that you're going to be having like decimal amounts. We're going to still just round to 2 decimal places. So it'd be like 28,518.12. That is the approximate population. And then the other situation is, when will my population double? When will the population equal 18,604? Go back in. Let's change this y to 18,604. And we can see 8.043. approximate time. Is it years? Years. Cool. All right. What if we're given a table? This is very similar to when you're given a graph, like finding the equation. What are you given a table? How can we write this equation? Well, you can see what the initial amount is, your amount at time 0. So you're already starting with A. But now we got to find the multiplier. If you remember how to do this off of the graph, you remember there is a certain value that we're going to be multiplying by to get from here to here. And it's the same value to get from there to there. And it's the same value to get from there to there. Same value to get to there to there. All we need to do is divide two sequential values to figure out what we multiply the previous value to get the next. So like 5,300 divided by 5,000, 1.06. 5,618 divided by 5,300. It might be a little bit off because of rounding, but it should be 1.06. 5,955 divided by 5,618. Might be off because of rounding, but it should be 1.06. Oops. 5,955 divided by 5,618 should be 1.06. I keep messing up. Yeah, it's a little bit off because of rounding, but we can see we are multiplying every single time by 1.06. Okay, we are missing the B value. We divide two sequential Y values. Sequential means they have to be one after the other. You can't divide 6312 by 5618 because you're skipping a year. You'd have to like kind of figure out what you're multiplying by squared. All right, so that's it. And this is the same deal. So that's it. Probably what I would do is go back and give you an equation, you find some values, and then I'm going to give you another situation, answer the same questions. And yeah, that'd be good. And then this is really just like if you had the graph, figuring out your multiplier. Maybe you could find R from here as one extra thing, B equals 1.06, or B equals 1 plus R. 1.06 equals 1 plus R, subtract 1, R is equal to 0.06, or a 6% growth. Cool, all right, thanks. Real world exponential problem.